Now here is a question based on integration of an expression given here. So if you observe, there are 4 different terms to be integrated and they are connected with plus and minus. So we can definitely take the integral of every term and then connect it. Alright, so if we consider the first term, it is x raised to 4. So which is of the standard form, which is x raised to n, right? Now the second term, which is root x, which is not in standard form. So we have to somehow write it in the form x raised to n, right? So let us write x raised to 4 as it is, minus 3. Now root x is nothing but x raised to half, correct? Plus we will write 2 upon x as it is, because out of 2 upon x, the term 1 upon x is directly integrable. And lastly, the term sec square x as it is. So basically in most of the sums of integration, our main aim is to bring the function which is to be integrated into a form which is directly integrable. That is, so now we can directly integrate. So integral of x raised to 4 is x raised to 4 plus 1 upon 4 plus 1. So I am purposefully writing the detailed formula since we are doing it for the first time. Minus 3 into x raised to half plus 1 upon half plus 1 as per formula, plus now integral of 2 upon x, in which 2 is a constant, so that will come outside the integration process, and what remains is 1 upon x. So we know that integral of 1 upon x is log of x, and strictly we write log of mod of x since we don't know the sign of x. And lastly, the integral of sec square x is nothing but tan x. So that is the last integral, and of course at the end we have to add the constant of integration. So simplifying this further, we get x raised to 5 upon 5. Now if you observe this, 1 by 2 plus 1 is 3 by 2. So it gets reverted and it becomes 2 by 3. So on multiplying, it will become just 2. And for x, we have the index as once again 1 by 2 plus 1, that is 3 by 2. So therefore that becomes x raised to 3 by 2 plus 2 log x plus tan x plus c. So that is the final answer. Right. Now if you want, just keep in mind that this x raised to 3 by 2 can also be written as x root x. So just remember, many times we need to rewrite this in terms of the power. So x root x is nothing but x raised to 3 by 2. Alright. Now let's go to another question. Now in case of integrations related with trigonometric functions, often it is needed to somehow simplify the given expression, and doing that it becomes very easy to integrate. So if you see this question, we have to integrate 1 upon sine square x into cos square x. Now on its face we don't recollect any function which is the integral of this given function, because it's not a simple standard function. So we apply one trick here, that is the 1 which is present in the numerator, we break it, or rather express it using already known identity as sine square x plus cos square x, isn't it? Divided by, we have sine square x into cos square x. Alright. Now suppose we split the fraction, that is the first portion upon the denominator, that is sine square x upon sine square x into cos square x. That gives us 1 upon cos square x, correct? Plus if we bring the other part also in the picture, we get cos square x upon sine square x plus cos square x, which gives us 1 upon sine square x. This is what is to be integrated. Now if you just rewrite 1 upon cos square x as sec square x and 1 upon sine square x as cosec square x, then it will be immediately apparent that these two functions can be directly integrated, because we know that integral of sec square x is nothing but tan x, right? And integral of cosec square x is minus cot x and plus c. So therefore this is the final answer. So it's a very important point that in case of trigonometric functions, we often need to use some identities, simplify the given function so that it can be integrated.